I will talk about a technique that I also did a workshop on Monday. So a couple of you guys probably were there and know the whole story. Lean inspections is something really, really old, actually. And it was the first roots happened when Fagan did his work on inspections. And that was, what was the date? I was 5 years old. So who in the room got into the software business before 76? Show of hands. Oh, one. I don't believe you. You look too young. Who got into the software business when Tom Gilb actually did most of his work on inspections in '88? Before '88, anyone? Nobody. How about the next phase, when Tom joined forces with Dorothy Graham and did a very good book on software inspections in '93? Anybody? Oh, there's one, '93. Okay, and the next one then is very, very good. I cannot recommend it strongly enough that you read it. It's The Competitive Engineering of Tom Gilb in 2005, actually. Anybody? Join the, okay, now we're talking. Actually, Niels, you saw him. Niels, are you here? He's not. You know, has more interesting things to do. He did the last bits of the work that I will comment on here. And then you see there's 8 years until now. There's nothing really happened since then. It's really, really old news. But can I have a show of hands? Who of you uses inspections in their projects? A couple. Very good, very good, very good. So what I'd like to present here is a case study, basically. But not everybody is familiar with the idea of the inspection, so I will just briefly go over it and tell you what it is, actually, and then show you quite some data that I collected during the case study there. That was a couple of years back, but I think it's not important where it was. So the basic premise for us when we started on this project was, how can we go about the software project really, really fast, and how can we get value out the door and leave it there? And by this I mean, can we please not have to rework things? Can we just produce things and implement it, code it, put it out there, and then it's there, and not take it back and remove all the bugs and stuff like that? So that was basically the idea. How can we do that? And the only way I know how to do that is to do it right the first time. This sounds very simple, but it is hard to do if you think about it. So I come from a world where oftentimes systems live very, very long, and they compile a large heap of bugs, like this one. It's just, it starts off well, first release good, second, third, all fine, but after, say, 10 or 15 years, the system is a mess. I think that happens a lot. So the only way I know how to prevent this is to do it right the first time. I just said that. And to do it, you have to look at the process. Up there's a picture of a typical process I see in projects, and this is also a picture of the project that we did. So you do something, you write something, you test it, then you fix it, everything that didn't work. If you're lucky, you test it again, but most of the times you fix it and don't test it and push it to production. That is quite typical, was quite typical at the time. So you can also go about and do it in iterations. That's slightly better, of course. You can, do parts of the system, then have the same cycle that I just explained, and start over again, basically. I think there's a much better way to do that, and this is what I call the lean way. The basic idea is that whatever you produce a very small batch, you inspect it, make sure that it's really, really good. then change your process accordingly to make sure that you never make a mistake again, the same mistakes again. Then you rewrite the whole set, whatever it was. So not fix it, but do it again, and you can do that because you just did a small bit of it. And then do it in iterations. So basically, this is lean. I call it lean because that's the basic idea behind the PDCA cycle. You have to change your process, and by process I mean in a very broad sense. Maybe you come up with some new checklists or whatever it is, or you find different tools or things. So the basic idea is to come up with that step down there. You have to change your process before you proceed. That's the essential part here. So in the case study I found, and there's lots of data on different projects on the net and in the books, but on my project I found that, okay, by doing it this way, the way I just showed, you can be 5 times more efficient and you come up with 90% less defects, actually. So you can avoid a lot of mess further downstream. So the basic idea behind it is you come from a state where you're finding and fixing defects. You can then move on to something I would call, you can really check quality. It's not about finding and fixing, but to have a measurement of quality. And the third step then is to actually make a decision based on the data. And the decision is it good enough what we have here? Can we work with it? And basically, what the whole process does, and what a very important point that Tom Gilb up there pointed out to me, is that actually, you should choose your process so that you can make everybody on the team a hero. I say it again because it's very important. Can you and your process on your project, can you produce heroes? That's a very interesting point of view, I think. How can you promote organizational learning and reduce the time that you need to have the value at the customer? You know, that's just what we just heard in the last talk, and a couple of other things. And yeah, you can do that, and it's quite easy. You have to measure and then adapt. That's inspect and adapt in Jeff's Scrum Guide, of course. And the basic measure is a fair idea of the defect density in a given product. Defect density, or major defect density, I will come to the idea of major and minor defects in a minute. But basically, this is just a number. And you can use the number to make a decision, is it good enough, or move on, or how good is our process actually. So this is what inspections are. You're probably familiar with reviews. Reviews I see as, okay, you read whatever it is, code, specifications, designs, test plans, whatever is written down. That is reviews. You read it completely without any rules, and then you have an opinion about it. But in inspections, you would have a team inspect a work product with a couple of rules, say 3 to 5. Most of the time I go for only 3. Like, for example, is it unambiguous? If it's a requirement specification in this case, is it unambiguous? Is it clear enough to test and stuff like that? So this is classical Fagan inspections, actually. Tom Gilb did something really clever. He said, let's do it with statistics. Let's draw a sample from whatever we have here and not inspect the whole thing. Just 1 or 2 pages. Pages is more or less a concept. You don't have to have the idea of a page of a printout or something. A page just means 300 words. It's just for standardization. So really small sample, couple of checkers, and they check the sample according to the rules and just categorize and also count any defects. A defect is a violation of one of the rules that you used in the first place. And you don't comment. That's kind of counterintuitive. You don't comment on whatever you find. You just categorize it. You say this is probably a major defect or a minor defect. Come to that later. And then you count it. So how many of these rule violations are in this sample? That's the basic idea. And then you draw conclusions. Okay, if I found, say some number, I found 20 different defects, unique defects on that sample. It's not that uncommon, by the way, to find 20 defects in 300 words. And then you just say, okay, if it's 20 on that page and it's 10 pages, so it must be 200 in the whole document. That's it. And it's, of course, that's not very accurate, but it's enough to make the decision, okay, these 10 pages are really bad, we should throw it away and start over. You don't need more. So here, I'm going to start on the data that I collected, and I have to give you a little bit of context of the project. So we had the idea, okay, there's some business process we want to automate, we want to have an IT system for. There was none before, so it was kind of greenfield, and we came up with the list of things I would now call themes. So really, really big items of specification above epics, if you're familiar with the story, epics, and theme hierarchy there. We came up with a list, what probably are all the themes of the system, and we said, okay, this is about 100 themes, really big thing. How can we actually make sure that we develop a good system that is quite complicated? We knew it was complicated in the beginning. So we said, okay, 100 of these things, whatever it is, a theme, and we had 5 people who could work on the details. So subject matter experts who were able to tell developers, okay, this is what you really have to do with this theme and stuff like that. So 5 people, 100, okay, how to do that? We don't want to write everything and then check it, but use the what I just presented in the diagram, do it bits by bits. So start with something, maybe describe one of the 3 themes in a way, and find out what the team is working on and how it has to be presented to be good and stuff like that, and learn from that, and then start doing the next. You know, that was the basic idea, and of course it fit quite nicely with the sprint structure we had. Well, that was a couple of years back, so our sprints were 2 months actually. What I did, I was appointed the quality guy in that project. I wanted to find out, are inspections really much better than reviews? And of course, you need some angle to look at it. And so I said, okay, we want to measure the defect density of the specification we produce and find out if we actually get better. And the results, I'll show you numbers afterwards, is that actually when we used inspections, so we did 2 things. We used inspections on one set and reviews on the other set. And we found that inspections gave us much less effort that we needed for checking everything. That is, well, quite clear because you just draw a sample and not read the whole thing. It also meant that we spent a lot more time on the removal of defects because we found so many more. That's obvious too. And we ended up with less damage because of the specification. They were better and less remaining defects, of course. And the second thing that I tried to figure out was maybe it's a good idea to still have the reviews because reviews give you the extra advantage of having something read and then understanding the whole thing better. You cannot do that with sampling. But what is the order? And we found out that it's a really good idea to first do inspections and maybe then reviews, because the thing, whatever you inspect, is clean, and then it's the time you need to understand it and read it is much more well spent. So I calculated ROI for that. That's almost 5 to 1, and the net savings was about a quarter of the budget of the system actually. And then another important thing was that the people who did it, at first they were a little, should we really do this? This feels kind of strange, just looking at samples and then drawing conclusions. And after a couple of rounds, they said, "Oh, this is really good. We should always do this." So this data, it's not that important that you can read the values. The basic idea behind all these graphs is that in all categories, like the effort you need for checking, the effort you need to fix things that are in the specification in this case, and the damage that is done, and also the number of defects that are remaining. In all these categories, inspections score much better than reviews. Again, seeing this picture here, what we didn't get at first was that step over there, that we should change our process. And so we did the first couple of iterations in the descriptions, and then we came to a point where we did the second set, and it was much better because the authors learned something. That was the main effect, of course. But we said, well, next iteration is half of the defects, and then the next iteration again, half of that, so a quarter. But we felt like this should be much more efficient. And then we realized, okay, we forgot to change our process. And the basic adjustment we did there is to come up with better rules in the first place. Okay, what is it we really aim for? And then the second adjustment that we did is provide two types of checklists for to substantiate the definition of ready we had there. So definition of ready in itself is a checklist, but we provided details to the authors and also the developers, authors, the subject matter experts, but also the developers on what they should look for if they check a document, for example. So that was much better instruction for the whole process, and that gave us the last kick, so to say. So what we actually did was, one of the authors would come up and signal, okay, I'm done. Can you please do an inspection on that? We had a standby team, 2 to 4 people, depending on when it was in the project. You know, we got more people after a while to check the sample. And then we came up with the measurement of the defect density, and that's it. Of course, there was a lot of discussion going on after that, but not during the process. It's important that you have all your discussions out of that cycle. So we just measured and estimated, is it really good enough? So should we go on with it? And is everybody really understanding what good quality means in this case? So what we found in terms of our results is that we came from a measure of 20 to 80 major defects. Major is something where you would say, okay, if you fix it now, you would save probably 10 or more hours compared to if you fix it later. And of course, there's lots of statistic going in because not every defect that you find right now will turn up as a problem later on, stuff like that. But we came from a number of 20 to 80. That's quite, for us, that was quite shocking. So can you imagine you have a sheet of paper about that, 300 words, and you find 50 defects in it? 50? That's quite shocking. But we were able to do much better after the inspections. 1 round, 2 rounds, we got down to less than 8 defects. That was our target, actually. And then we did the review part, which meant, okay, reading the whole stuff, but reading was much easier because the specification was much clearer. And then we also found a couple of defects during the review phase. So we came down to a quality level of 5 to 6 defects per page. If you look up the literature in a mature organization who does this for a couple of months, even years, you get down to 0.25 defects per page. That is a target level that you could easily achieve. So a couple of more interesting bits from that project there. Sorry, I need to stop my timer. We had one really good author there. He was not just the subject matter expert, one of the subject matter experts, but also a trained requirements engineer. And he got this process very, very quickly, and he used it actually to his advantage. He was the quickest learner and the steepest If you plot the defects that he produced, if you plot it over time, it dropped dramatically after a very, very short time. So his ROI actually was 5.3, very, very good. And it was also not expensive to inspect whatever he did, because he got the idea, as I said, produce a small thing, learn from that, produce more. This is the basic idea behind it, and he got it really, really good. But there was also another person. He was considered an expert at first, but I thought that maybe something's wrong with his mindset or whatever. The idea was that when we inspected the first artifacts that he produced, he said, okay, this is all rubbish. There's not a single defect there. Everything what you guys say, you checkers say, it's not a defect. Even if you think it is a defect, it is not. I can tell you because I'm an expert. So after 2 rounds, he dropped out of the process. So he said, no, it doesn't make any sense to give you stuff to inspect. And we did the inspections without him then, and we found dozens of defects in his stuff. So of course I thought, well, maybe there's something wrong with my perception. So I checked with all the other people who checked his material and inspected them. They said, no, it's clearly defects. You have to fix that. We all fixed it, but he doesn't. And the end effect of that was that he left the project after a couple of weeks. Okay, that's basically it. That's the data I have there. You can always look at the slide deck. There's much more data in it. Calculations for how expensive is it per 300 words, and how much time is needed and stuff like that. So you can look that up. Yeah, thank you very much.